complementary, not complimentary. Although I suppose it might give you a compliment. Complementary events. But first, the or we were talking about on Friday. We are in the probability section. 2 sections covered on the quiz tomorrow. Remember, it is a quiz, so we don't have to start it right at the beginning of class. Might be time for a couple questions before we start. Why are we having it tomorrow? A couple reasons. It's a quiz. Number 1, not a test. Number 2, I did have you guys start section 9.7 over the weekend, but then realize, well, first of all, I said start it, go to where you would normally stop, go further by looking at the book examples and trying to dig in, be a little bit independent in your learning, etc., etc. Then I said, when you get stuck on 9.7, go to the review. Go to the review and then be practicing 9.6 and 9.7. But then also, third of all, the pre-ACT is on Wednesday, meaning all of my sophomores will not be in class. So there are a few different reasons as to why we're getting that quiz in tomorrow. So we're going to go ahead and get through as many examples today, and hopefully we can answer your questions, like, for example, where you might have gotten stuck in homework and or the review. We're in section 9.7. We're not talking about how many ways, although it might come up again from section 9.6. We're talking about probability. What are some synonyms of probability, guys? What are the odds? What are the chances? Good. What are the answers going to look like in 9.7? Big numbers or little numbers? Little numbers, because we're thinking percentages. And percentages are going to be decimals or fractions, right? That's where they come from. So we're getting percentages, or we're working with percentages, fractions, decimals, etc., etc., etc. We talked about and on Friday. What happens if we have an and that comes up? And now we're also talking about an or and complementary. There's one more big idea, and it's actually the very, very, very beginning of 9.7. Any probability, if you're finding it, can come from the idea of a fraction. You can think of the number of ways that this can favorably occur. Favorably means meeting the condition they give you, right? How many ways it can favorably occur over the total possible number of outcomes. Do you guys remember that special term for the total number, the favorable plus the unfavorable? What's that term? Look at the beginning of your notes, 9.7. What's the term for the total number of outcomes, the favorable plus the unfavorable? Good. So it's the number of ways that an outcome, you can get favorable. How many favorable outcomes are possible? How many ways can this favorably result over the total number or the sample space? That's how we in general set up a probability. But then the rest of what we were talking about, besides the standard deck of cards and how many aces, etc., how many black and red cards, we started talking about what if you have multiple conditions being brought together. There's an and that had a special symbol of an upside down U, kind of like an A, if we can find it. There we go. Sorry, I didn't realize I had it right here. This upside down U is a special symbol for the word and. The nice thing is we still have multiplication, like the fundamental counting principle. And this example, this is a different type of and saying, hey, one card, one event that's both black and even. That's one way of using the word and, but that's not the way that this formula is talking about. This formula is talking about if you have events A and B, like picking a black and then, separate event, picking an ace. What's the probability of picking a black card and then picking an ace, etc.? That's what this and is, 2 separate events. So there is a way of thinking about an and with the shared characteristics, and we try to figure out how many, for instance, in this example, how many cards are both black and even to figure out our fraction of number favorable over total number. But the and we're talking about, similar with the or, that we're talking about 2 separate events being put together with an and or with an or. So with the or, there's 2 things we have to think about. Well, one main thing. The one main thing is, can something be true at the same time? And we're going to look at examples in just a second, but this first formula says there is an overlap. Conditions A and B can be true at the same time. So if I was to add all the A's together and all the B's together, what did I just double count? Yeah, if I add all the A's and all the B's, I just double counted the overlap. So we have to say all the A's, probability of A, plus the probability of B, minus the probability of A and B, minus the overlap that just got double counted. However, if A and B cannot possibly be true at the same time, we don't have to worry about that because add all the A, add all the B, and we're done. So we only have to worry about this extra subtraction if those two events can be true at the same time. Now, complementary events. The complement are the chances of something not happening. Notation, here's one example of notation. The book might show other ones. Let's say the probability of A, that's one way of showing it. The probability of not A. Those of you guys that got into this section, did you see the other notation? I think there is an alternate notation. I just realized it this year for the first time. No one ever talked about it before. Did you find it, AJ? Oh, here we go. The way the book also shows it is with an apostrophe. Probability of. So either one, they both are going to mean the complement. They're both going to mean the chances of something not happening. And actually, you guys already did this one. You don't even need me to tell you how to do it. I'll use the book's notation to solve or to show the formula. Because the other day, didn't I ask Noah his free throw shooting percentage? What did he say? 0.88. And we had to plug into that formula the probability of a success of making it. But we also had to plug in the probability of a failure of not making it. And what did you guys all do to answer that question? If his percentage of making it was an 88%, how do we fill in the other one, which was the percentage of failure? Subtract it from 100%. You guys got 12%. So how do we do it here? We can say 1 minus, wait, why am I showing 1? Because it's the same thing as 100 minus the probability of A. Can I just put I don't mean the decimal. So you would do 1 minus the decimal, 1 minus 0.88, or 100% minus 88%. So if I was to say today, the chances of rain today are 5%. I just made that up, but it is sunny. Chances of rain today are 5%. What's the chance of it not raining today? 95%. Good. The chances of it raining 5%, the chances of it not raining, subtract from 100. 95% is left. Okay. And this only works when, well, it's only simple when you have chances of something occurring, not occurring, and there's no in between. Either something occurs or doesn't occur, which is kind of like Noah. He makes it or he misses it. Kind of like we were asking for yes, no, like heads or tails.
I need to leave early today, so should I take the test quiz tomorrow, or should I take it?
Lainey, come over here for just a second. Kiddos, let me go ahead and talk with Lainey, and as I do... You guys read the scenario. Computer selecting 3 integers, 1 to 20. Probability all 3 numbers are less than or equal to 5. All 3 numbers are less than or equal to 5. What do you guys think? Is it an and? Well, is it a simple fraction? Is it an and, an or a complement? What do you think? When it says all 3, I'm not sure that's an or. Because I think the first one has to be true, and the second one has to be true, and the third one. Does that make sense why it's an and? Okay, so does it make sense why I'm making 3 blanks?
Yes.
Okay. We can do this separate ways, but here's probably one of the easiest ways. According to our and formula, probability of A and B occurring, we can think of just the probability of A, or the first thing happening, and then separately think of the probability of the second thing happening. And in this one, and the probability of the third thing happening. So question, if the computer is randomly generating one number, what's the probability that the number it chooses is less than or equal to 5? How many ways could that favorably happen? How many numbers are less than or equal to 5? 1, 2, 3, 4, 5. 5, right? But it's 5, because it's not 0, it's 1. 5 out of, what are the total numbers it could choose from? Does that make sense?
Yes.
Now, does this say that the computer can't choose the same number 3 times? Or it can't repeat? No, computer can repeat. It doesn't have like set tiles. It just has a qualification. So technically, what's going to be the probability is you get to it choosing another number. Still 5 out of 20. Nothing has been deducted. There's nothing that we need to take away from the options. So we can just keep on multiplying. There you go. The other way of looking at it is you could have said, how many ways can you get a number less than or equal to 5? 5 and 5 and 5, like section 9.6. How many total numbers? 20 and 20 and 20. So you could have also done the separate fundamental counting principle twice in the numerator and denominator, or you could think of the probability, but both answers will be the same thing. So 5 times 5 times 5. Well, hold on. Isn't that just 1/4, 1/4, 1/4?
Yes.
Sweet. So it's going to be 1/64, which you could answer as a fraction. You could divide it and get a decimal. You could take that decimal and make it a percentage if you want. Does that make sense? Kind of. Okay, what do you guys think this one is? What's the likelihood that you would draw a red 4 from a standard deck of cards? Is this a simple fraction? Is it an or a complement? Simple fraction, hopefully. If you can get used to cards, you can think about, okay, deck of cards, what's going on? How many cards total? We wrote this down on Friday. Okay. How many meet the special qualification of being a red and a 4? 2. Could either have a 4 of hearts or a 4 of diamonds. Yeah. So 2 over 52 could reduce to 1 over 26. That's good. That would be the final fraction, which could be made into a decimal, could be made into a percentage. So you see the difference between something that needed ands, because there were 3 separate events, or something that just needed one simple fraction? To think about the number of cards. And so if you're not familiar with cards, remember, we wrote down on Friday and we talked about it in the video. If you need to go back and listen, maybe go play some card games to study. Just kidding, maybe not. But coming back, I don't know if poker specifically would help you with probability studying for the quiz tomorrow, but the idea would be there. If you ever get forced into a poker tournament and you're going to lose money if you can't win. Anyway. Or if you need to be able to bluff, which I don't know if that's always a good. Okay. Hey guys, this one's really obvious. Is it a simple fraction? Is it an or is it a complement? It's an or because it says or. What symbol could be there instead of this? Black. Now, ready? Either there's a symbol that's like this, or there's a symbol that's like this. Doesn't this one look like almost like an A? Hey, this one goes with and. Stands for the word intersection or and. So what's the or going to be? The other one, union. Anyway, black or numbered. What's the operation for numbered? Sorry, for or. Lo siento. You just wrote this down a second ago. Yeah. So what's the probability of getting a black card, first of all?
26.
Good. We have 26 ways that we could get a black card, and we could put out a 52 thinking about probabilities. Bless you. What's the probability of us getting a number card?
40. 40. No. There's only 4.
4 suits.
3.
How many number cards?
Oh.
There's no 1. Starts at 2 and goes to 10. So it's 1 through 9, but 2 through 10. There's only 9 options, right? So 9 times 4 is 36. Does that make sense, though? 2, 3, 4, 5, 6, 7, 8, 9, 10. 9 options. Now, question. Why is this really, 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 really bad if we were to add this right now and get this to be 62 out of 52? Are there more cards than black or numbered cards? I know, lo siento. Are there more cards than black and numbered? What about the red non-numbered? What about the red aces? What about the red face cards? How do we have 62 out of 52? There's an overlap. Aren't there some of these black cards that are also numbered? So we added some black cards into this total that were already a part of the equation. So this is an example where you have to subtract the overlap. And the overlap would be the black numbered cards, A and B, both black and numbered. So therefore, how many black numbered cards are there? 2 suits of 9 each. Wouldn't that be 18? Oh, maybe that makes a little more sense. Because 62 minus 18 is going to end up being 44? Is that right? 50, 62? Yeah. And does this allow for, oh yeah, those red aces, and oh yeah, those red face cards? Yeah. If you want to double check, 12 cards. How many face cards / aces per suit? Not 12. I apologize. I can't subtract. Isn't that 8? Lo siento. Yeah, 4. So 4 and 4 is 8. You guys could reduce. Did anybody reduce yet? What does it divide into? 4 goes in 11 times, and 4 goes in 13 times? There we go. What's the probability of getting a red card or an ace? So what are we going to do? How many red cards? Half. How many red cards? Half. 26 out of 52. How many aces? 4. But how many of those aces are red? Does that make sense? So ultimately it's going to be 26 plus the 2 black aces. So we're going to end up with 28 out of 52, which ends up 7 over 13, I think. How about the probability of getting a jack or a heart? 4 jacks, good. Not jokers, jacks. How many hearts? 13. 1 suit is 1/4. Ooh, how many jack of hearts? Or, yeah, right? So that's going to be 16. Do you guys kind of get the feel for needing to subtract the overlap if it's there? Okay. So let's change the example. Rolling a 6-sided die and getting a 3 or an even. How many options are there in a 6-sided die? So a 3 is how many of those numbers? Okay, so 1 out of 6 plus an even number, because it's just 2, 4, 6. You only go numbers 1 through 6. So 3. Do I need to subtract any overlap?
No.
Because 3 is not an even. So these are 2 mutually exclusive events. There's no overlap. 3 isn't an even. So the 3 is considered here. The evens are considered there. And you guys could say if 3 are even, well, 2, 4, 6, and then 3. So 4 out of 6. But you could get it this way as well. Yeah, which could be made into a decimal, could be made into a percentage. Does that make sense? Okay. Ooh. Remember when we talked about with Noah's free throws? That at least got a bit more complicated. Let me zoom in on example number 11. At least gets a little bit more complicated. Not impossible, but a little bit more complicated. A manufacturer has determined that a machine averages 1 faulty unit for every 1,000 that it produces. Yeah, it's not too bad of a percentage, right? Let me see if I can zoom in. There we go. 1 faulty unit for every 1,000 that it produces. What is the probability that an order of 200 units will have 1 or more faulty units? 200 units will have 1 or more faulty units. Here's the crazy thing. Without getting super complicated, do you guys remember in 9.5 probability came up with the binomial theorem? And it was talking about how if we wanted to think about the different possible considerations, the different possible groups of ways that something could occur, we would have to think of the success with the failure. Long story short with this one, we would have to, in order of 200 units, having 1 or more faulty units, we'd have to go through and say, hey, what if out of 200, what are the different ways that we could get just 1 faulty unit? Because 1 or more, right? And with that 1 faulty unit, we would have, okay, hold on, what's the probability of getting 1 faulty Just probability of getting one faulty. Good. Be 1 over 1,000. What's the probability of getting not faulty? Yeah, 999 all over 1,000. We would have to do the percentage of success, basically 1 over getting a faulty one. That would be to the 1. And then the other for the other 199. And that's just how many ways you could get one faulty unit. Now what's the struggle? This says 1 or more. So what would we have to do? What about 2? Do you see a struggle? What about? That would be 198, right? Ha! We'd have to go all the way up until we had 200, because that'd be at least 1. 200 faulty and no non-faulty. Now, how tedious and disgusting does that look? It's basically expanding a binomial. The struggle is that's going to be ridiculously long. Sometimes it's easier to think about, hey, look, the complement. Sometimes it's easier, instead of adding up all the ways it could happen, to ask yourself the question, when will it not happen? And let's subtract from 1 to find the rest. So let me give you an example. What's the one way you would not have the complement? What's the one way that you would not have at least 1 faulty? If you had all good ones. How would you do all good ones? Out of the 200, no bad ones. None of the 1 over 1,000 chance. All of the 999 out of 1,000 chance. Another way of thinking about it is 200 blanks. All of them, 999 out of 1,000, 999 out of 1,000, 999 out of 1,000. All of them, you got the good one. And if you were to plug that into your calculator, the nice thing is, anytime you have 200C0 or 200C200, that's the beginning of Pascal's or the end of Pascal's. And guys, what numbers are always at the beginning or at the end of Pascal's triangle? It's always a 1. So automatically that's just going to be a 1 as far as how many groupings. So all we need to do is 999 out of 1,000 raised to the 200th power. And we end up with, you guys want to double check me, 81.9%? There's an 81.9% chance that you will get all 200 good ones. So question, what's left over to get to 100%? Getting at least 1 faulty. So how do I do that? Because that was the whole point. All I have to do is say, well, everything that's left from the getting all good must be in this camp of getting at least 1 bad. So therefore, I would just do 100% minus 81.9, or 1 minus my decimal. And I would end up with 18.1 without having to do this ridiculously long addition. So the idea of a complement, sometimes it's easier to add up, instead of adding up all the ways something could happen, figuring out the way it couldn't happen or wouldn't happen and subtracting from 1 or 100% instead. Kind of makes sense how it made it easier? Cool. Guys, that's the end of section 9.7. I know that you might have some questions on homework and or reviews. So open up that homework spiral if you did get stuck somewhere and today didn't answer it. And as we're looking at that, there we go. For the quiz, for the quest review, some of you might want to write down that problem. Jackie, you had a question. Go ahead.
Yeah, it was actually the last example that I just said.
Yeah.
So, how come you use C and not P, like the NCR?
Oh, because the order didn't matter. The order didn't matter as far as, like, it was kind of like the TV example we did a little while back, where if you open up all the boxes, we don't really care, like, where the faulty one falls, just that it's in the group. And the group would be a combination. So like if you had all the units lined up, permutation would say, oh, it's the second one that's the bad one. That's different than if it was the 10th one that was the bad one. And in us, we're like, we don't care, just that there's a bad one in there. Does that make sense? Jacob.
If they didn't ask for one or more, but just ask for one, it would be just 20%. If it was one for every 1,000, it would be 1/5 for every 200.
No, it wouldn't be 1/5. I know what you're trying to think of, like going to two, because you're like, oh, 200 out of 1,000. But you're not taking into consideration that 1 out of 1,000 is the chance of getting a faulty one.
I thought 1 out of 1,000, I thought 1/2 out of 500.
Oh, 1/5 out of 200. Sorry, yes, that makes sense. I thought you were saying 1/5, and I'm like, huh, way too big, but that makes more sense. Thank you. Okay. For those of you guys that started section 9.7 in the chapter 9 quiz review, chapter 9b is what we're calling it. This is last 2 sections. Are there any questions that you wanted to ask me from section 9.7? Actually, here, let's do this first. You guys have had a chance to write down. There's, guys, only 6 review questions. Why? Because we already did chapter 9a review, and that's not what's on the quiz tomorrow. It's just probabilities, 6 problems. It's on your homework sheet if you wanna write it down. So just think that your homework is just a little bit longer for 9.7. But for section 9.7, I'm recording right now, right? Some of you don't have 9.7 totally attempted. Some of you should be grading it right now because you do have it attempted, but the rest of you, aren't the answers online for you to check out on the video tonight? Yeah. Come tomorrow with questions on 9.7. I won't grade it in class, but I will ask before the quiz any questions. So I'm going to go ahead and scroll slowly through the answers. Some of you guys are able to be checking, and some of you are going to need to check tonight. Come tomorrow after trying the review after section 9.7, getting online to the YouTube, just scroll into the end of class, and checking the answers, and come with any questions that you have. But anyone who has been able to grade or knows they have a question, Nick.
Our notes and homework are due.
Yes. Notes and homework are due tomorrow like normal. Notes, I'll probably just have you guys hold up your table of contents. I'll just run around, make sure it's up to date, and then show me, because you can just flip with your finger and show me. It'll just be really fast. So we'll do a quick spot check instead of you guys passing in your notes. And then homework spirals will go back on the TA desk like normal. After we go over the couple questions that we might have, we'll just pass them all straight back. Besides that, you will be allowed to use your calculator on the quiz tomorrow for the whole thing. But remember, I said I might put a blank on there for a factorial formula. Let's see, when are there factorial formulas? NPR and NCR. But otherwise, you'll be able to use your calculator the whole time. But question, with probability, can you always just read the problem and plug it into some nifty function in your calculator? No, you have to be able to realize, is it an and? Is it an or? Is it how many ways? A big number? Is it probability, fractions, or percentages? Those are the big questions to ask. What's the difference between permutation and combination? The order being important. Which one is order not important? Combination, like a combo pizza. I don't care, just that the right grouping of toppings are on there. Groups. Combination. Permutation, order is important. One other note that you might want to study. Remember that funny repeated objects thing, how we had to divide by something special? It's kind of unique, and you might not remember it if you don't study it. So I would go back to 9.6 and study the repeated objects. It's just something people frequently forget to think about. I think those are all the evens. Oh, nope, sorry. There was one more even. I apologize if you were grading. If some of you guys are realizing it, these are going to be ands, hence why they're multiplying like 2 blanks. I think this is getting it, percentage of success, so squared because it's twice. Percentage of failure, multiplying twice, that's why it's squared. And then here's one of those, the complement was way easier to solve, so 1 minus. All right, so no questions, 9.7 or the review? AJ? 37 on 9-7? Okay. We'll peek at that together as a class before we end. So number 37 says, in a high school graduating class of 128 students, 52 are on the honor roll. So they're giving us like a lot of numbers. Of these, 48 are going to college. Of the other 76, 56 are, 48 are going on to college, 56. Oh, talking about honor roll and not honor roll. Sorry, I didn't notice that. What is the probability that a student selected at random from the class is going to college, not going to college, not going to college, and on the honor roll? Don't we have, for letter A, don't we have out of 128? How many kids are on the honor roll going to college? 48. But don't we also have the non-honor roll kids who are also going to college? So we had to consider them also. So we had to add the two together. For letter B, not going to college, of the honor roll, that was subtract 4. And on the other ones, we would subtract the 76 and get 20. Does that kind of make sense, AJ? So we had to consider the honor roll and the not honor roll. And then letter C, not going to college and on the honor roll. Oh, wait. That was this one. Not going to college and on the honor roll. Isn't that just 4 out of the 128? Because it's not saying choosing 2 different students, not on the honor roll, and then, not going to college and then not on the honor roll. This is one where it's 2 characteristics in one. So how many kids are both not going to college and on the honor roll? 4 of them were both conditions. It's kind of like how many black aces.
I'm sorry, I'm still confused. Wouldn't it be 4 out of 50? How many is on the honor roll? 52?
Probability that selected at random from the entire class.
Oh, okay.
Yeah, from the entire class. So 128 was on the bottom. Because only 4 of the honor roll, because it said on the honor roll, only 4 of the honor roll are not going to college. Does that make sense? So it was a lot of trying to figure out what the numbers meant. This one's on the video too, so when you guys get to 37, if you do get stuck, a lot of characteristics, you can check it out. Otherwise, the imaginary bell beep ran. Today, Q&A chapel with some amazing guys that love Jesus and love you guys. Hopefully it'll be practical, hopefully helpful. I'll see you guys in there.